Key features of absolute value functions. Okay, so these key features we're basically working with the exact same key features we worked with quadratic functions. So I'm not going to go through and talk through all those. So let's just jump into it. Determine the key features of the following graph absolute value functions. Okay, so the domain on this is all real numbers. And the reason being is because of these arrows. It is going to go on forever in the positive x direction. It's going to go on forever in the negative x direction. It is never going to stop. So it's all real numbers. Now the range is not all real numbers. Remember, range is referring to y. So this is never going to go below -5, right? The graph is only above -5. So the range is when y is greater than or equal to -5. So that would be the range. Now the increasing interval, so I'm going to do increasing interval and decreasing interval together. So I'm reading it left to right. So it's always we're always reading it left to right in terms of increasing and decreasing. So it starts off decreasing. And then, so decreasing. And then it's increasing. So again, we're reading it left to right. When we're defining these intervals, we're always saying as x increases, what happens? So as x is, we're going to the right. Okay. So it's increasing, and you can see the switch happen at 2, right? When x is 2, it changes from decreasing to increasing. So the increasing interval would be when x is greater than 2, and then the decreasing interval is when x is less than 2. All right, I'm going to erase that, these scribbles so that it's clear enough for us. Now, the positive interval is when it's above the x-axis. When we're talking about positive, we're just talking about when it's above the x-axis, when the y values are positive. So it's positive in a couple places, here and here. It's positive in those two parts of the graph. And those two parts of the graph can be defined like this. So the left side is this part over here on the left is when x is less than -3. And another time it's positive, right? And is this part. And that's when x is greater than 7. So those are the times it's positive. The times it's negative is this whole time. And this time is between the -3 and 7. So I would say it's when x is greater than -3 but less than 7. Now, in behavior, as the term says, is how the graph behaves at the end for very large values of x. So as x goes to positive infinity, which is out here, the graph's going up. In the y direction, the y is going to positive infinity as well. And even in the negative infinity direction, when we go to the left, the graph's going up to positive infinity. It's going up to positive infinity in both directions. That's the end behavior. Let me show you another. Domain, again, this one's all real numbers. Because of those arrows, it's going to keep going to the right, keep going to the left. The range, though, has a restriction. It's never going to go above 3. In fact, the entire graph is below 3. So the range is going to be y is less than 3, less than or equal to 3. Now let's look at the increasing interval. So I'm going to read it left to right. It's increasing, 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 increasing that whole time. And then at -1, then after -1, it starts to decrease, 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 decrease. So it's increasing when x is less than -1, and then it starts decreasing when x is, let me use red actually. It starts decreasing when x is greater than -1. Now let's talk about the positive and negative interval. So remember, positive interval when it's above the x-axis. So it's positive and this part. And that part is between -4 and 2. That's when it's positive, between -4 and 2, when x is greater than -4 and less than 2. It's negative in a couple intervals. It's a negative in this spot, and then negative in this spot. So this first spot here, that can be defined when x is less than -4. And this spot can be defined when x is greater than 2. That's the times when it's negative. This end behavior looks like it goes down in both directions. So as we go to positive infinity to the right, it's going to negative infinity. And even as we go to negative infinity on the left, it's going down to negative infinity. It's going to negative infinity in both directions of x. I'll let you do C. Also, you can do number 2 as well. Just plot the points and do the same thing. I'm going to do just one. I'm going to do A for number 3. It's the same thing, except just a little review of the graphing that we did in the last lesson. So this one, its vertex would be at -1, 4, or it's opposite of that positive one in there. So -1, 4, so it's going to be here. And then its slope per se would be -2. So I'm going to be going down 2 over 1. It should be opening down this V-shaped graph. So that's how this one's going to look. So let me do the key features here. I'm not going to scribble all over the graph because it's going to interfere with my ink. So the domain on this is all real numbers. The range, the highest it goes is 4, but then it's below 4, right? The graph is below 4. So I'm going to say y is less than or equal to 4. The increasing interval, so this is where it's increasing and then it decreases. So it's increasing when x is less than -1. -1 is that kind of switch point to where it goes from increasing to decreasing. It's the vertex. And then after -1, so when x is greater than -1 is when it starts decreasing. Positive interval. So I'm again looking at the x-axis. It looks like it's positive from -3 to 1. So like, I don't know if you can see what I'm bolding here, but like the x from -3 to 1 is when it's positive. And it's negative in a couple spots. It's negative when x is less than -3 and when x is greater than 1. And the end behavior for this, it's negative in both directions. So I'm going to go negative infinity in both directions. As x increases, y decreases. And even as x decreases, y decreases. It's going down in both directions. So I'll let you finish up the rest.